Yes, good evening everyone and welcome once again to the channel, and we are going to learn spherical mirror formula derived from how we can derive the spherical mirror formula from Fermat's principle. Okay, so spherical mirror formula, just write over here spherical mirror formula. Okay, we have to derive it. We will derive it using your spherical mirror formula. We will derive it using what? Using what? We will derive it using Fermat's principle. Okay, derive this using derivation of this. This is your spherical mirror formula. Okay, so derivation of this using Fermat's principle. This we have to discuss in today's class. Okay, now first of all, when you write the spherical mirror formula, okay, what do you do? Whenever you write the spherical mirror formula, what do you do? You basically, see the various meaning of the various terms in this spherical mirror formula. I am going to tell you. U is equal to your object distance. U is equal to object distance. V is equal to your image distance in this formula. Okay, R is equal to your radius of curvature in this formula. Okay, and F is what? What is F? F is your focal length. Okay, F is equal to your focal length, and this holds for spherical mirror. Okay, and your focal length, you know this very well, that your focal length is equal to half of your radius of curvature. Okay, focal length is equal to half of your radius of curvature. You have learnt in your lower classes. Now we will draw the figure. How does the figure look like? We will look at that. Okay, how the figure looks like. So we have a figure of this kind. Okay, a figure of this kind where, just a second, I will have to redraw it. Okay, just let's redraw it. So suppose we have a figure of this kind. This is your axis of the mirror. Okay, this is AO. Okay, this is paraxial ray AP. What does it mean by a paraxial ray? Paraxial ray means this is your line, right? This is your line which is perpendicular to the mirror. Okay, this AO line is the line which is axial. Okay, this is your axis of the mirror. So this AP is a line which is called as paraxial line, as it is very close to this axis AO. Okay, it will be at a very small angle from this axis AO. Okay, so such a ray is called as paraxial ray. You must know this. So AP is your paraxial ray, and this is your center of curvature C, and your perpendicular from P, foot of perpendicular is at N. This particular distance ON is equal to your X. Okay, and this is your H. Okay, now when this paraxial ray, this optical length is L1, AP, its length is L1. When this AP hits this mirror over here, the reflected ray is coming over here like this. Okay, and this is normal to the plane spherical mirror. This dotted line CP is normal to the spherical mirror, and your this we are considering basically two rays, intersection of two reflected rays, this is your concave, spherical mirror. Okay, this is your concave spherical mirror. So in this particular case, when the light ray AP is coming over here and it is getting reflected at PB, okay, this is your suppose point B. Okay, so what happens is that I consider a ray which goes from A to O and then from O to A. Like this, ray will come from here and it will go reflect back from here. Okay, so it will retrace its path. This particular ray, light ray, which will come from A towards O, it will retrace its path because it is coming normally to the mirror. Okay, so from point P, this is the reflected ray from point B. This one is the reflected ray from point P, not B, point P. Okay, and this is your reflected ray from O. So where the point at which they intersect is point B, and point B is the point where real image is formed. Okay, so B is equal to point of real image. Okay, point at which real image is formed. Okay, so B is the point at which real image is being formed. Okay, and this will be basically after reflection. This is your reflection. So this will be what? This will be your L2, right? This will be your L2. Okay, this will be PB. Length of PB will be your L2. Okay. So now this will be your what? You only tell me. Okay. This will be your radius of curvature R, right? From here to here. Okay, from here to here, this will be your R, because when you try to complete the circle of this mirror, it will have its center, that circle will have its center at C. So C is your center of curvature. Okay, and R is your radius of curvature of this spherical mirror. Okay, and what will be V? V will be OB. OB is equal to your V. Okay, that is your image distance. As image is being formed at B, so when we measure the B distance from O, it will be what? It will be your V. Okay, so it is getting very congested over here, but yet you can understand everything. Okay, if you draw it in the fair, then you will understand everything clearly. Let us once again draw it properly in a big sized manner. Okay, so this is your big mirror, this is your AO. Okay, this is your paraxial ray AP. Okay, this is your foot of perpendicular from P, but that is equal to Pn. This is H, this is X, ON is equal to X. Okay, this is your equal to L1. This is this goes from here and retraces its path, reflects back at the same point. This from P it is reflected, and it is reflected from P, so it is equal to L2. Okay, and it is being intersected at point B. Okay, C is your center of curvature of this mirror, right? And distance from here till here, it will be equal to R, that is radius of curvature. This is your what? This is your object A. So object distance is equal to your U. Okay, B is what? B is your image. Okay, so this will be your image distance V, right? So basically you have, and this will also be equal to R only. This dotted line which is normal to the spherical mirror, this CP will also be equal to R. Okay, CP will also be equal to R only. Got it? And this is your, suppose I label this mirror as capital XY. I label this concave mirror as capital XY, and these dotted lines at the back side, these dashes like this on the back side of the mirror, they reflect what? They show what? they show that there is silver coating on that side. Okay, it shows that there is silver coating on that side of the mirror. Okay, means this side is means that side has basically your silver coating. Okay, silver mirror, silver coating, you know na, that mirror has silver coating on account of which it reflects. Because of silver coating only a mirror is formed. Whenever a glass is taken, a piece of glass is taken and silver is coated on its back, then you get what is called as your mirror. Okay, so that's the thing. So in that way, now as you might have drawn all this in your notebooks, so I hope that you have drawn it in your notebook. So let's move on and let's see further. Okay, now XY is what? XY is your concave mirror. Okay, let's once again write it, concave mirror. Okay, if you have drawn the figure, then you will understand everything. AP is equal to your paraxial ray. Already explained. B, what is point B? Real image of object A. Right? C is what? Center of curvature. Right? CP is what? CP is your radius of curvature. X is your very small. We have considered that the refractive index of this particular portion, okay, the refractive index of this particular portion, the refractive index of this area, okay, the area which is over here, this particular area, its refractive index is equal to 1. We have considered. Okay, we are not considering any medium over here. We are considering that its refractive index is 1. Okay, got it? That's our assumption in order to simplify the situation. Now you know this very well, that the thing which I showed over here, okay, this thing, which you might have drawn in your notebooks, this X will be very small. Why it will be very small? Because this is your paraxial ray. This is your paraxial ray, AP, that is your paraxial ray. That's why X will be very small. Okay, so that's a common sense thing which you must understand. And N is equal to 1. These are two assumptions that we have with us. Optical path will be equal to what? You only tell me. By now you must have understood the figure well. Optical path, what will it be equal to? Optical path L is equal to AP plus PB, right? Which will be equal to L1 plus L2. This is common sense, right? You must look at the figure once again. You will understand. Okay, AP plus PB. That this is your optical length. Okay, which the light has traveled. It went from here till here, and then it reflected back from here like this. So that is your optical length. Okay. So optical path is your this. There, let this be equation number 1. And it is equal to L1 plus N2 because we have taken N equal to 1. That's why it is L1 plus L2. If N would be something other than 1, if suppose we would have considered that it is not vacuum or not air, it is something else, some other medium, then this N value will not be 1. In that case, there will be some other expression. It will not be L1 plus L2. L1 divided by something, L2 divided by something will come. Okay, so that's a different thing. But we have considered for simplicity N is equal to 1. That's why optical path is equal to our L1 plus L2 over here in order to simplify our case. Now by Pythagoras theorem, PC square is equal to Cn square plus Pn square. How? Just go to the figure and look at it. Go to the figure and look at it. Okay, what we have written, PC square, this is your PC. Okay, look over here, this is your what? This is your PC. Okay, this is your PC. Now PC square is equal to Cn square. Cn is equal to this much. Okay, and Pn is equal to this much. Okay, so Pn is equal to your H. And what is this Cn? Cn is equal to OC minus On is equal to your Cn, right? So you got it. So we will write now. So we will write over here. That is equal to your OC minus On whole square plus Pn square. Okay, got it? Then what happens is that this can be further written as r minus x square plus h square, okay, from the figure. So we are deriving the spherical mirror formula using Fermat's principle. That's it. We are doing nothing. You know this very well that your PC is what? PC is equal to your r square, because PC is equal to your radius of curvature. So what happens is that your total expression becomes what? Your total expression becomes something like this. Okay, your total expression becomes something of this kind. It comes out as r square is equal to r square plus x square minus 2rx plus h square. This is what comes out to be your expression. Now r square and r square cancel out, so your x square minus 2rx plus h square, that comes out to be equal to your 0. From here x square plus h square is equal to 2rx. This is suppose your equation number what? Equation number A, suppose. Okay, this is your suppose equation number A. Then we will have one more equation with us. Which equation? L1 square is equal to your AP square. From the figure you can look at it. Okay, now I won't go back into the figure. An square plus np square by Pythagoras theorem. Okay, these are very simple things. Then OA minus ON square plus np square, this will be okay, and OA minus ON is u minus x square plus h square, okay, which is equal to u square minus 2ux plus x square plus h square. Okay, got it? So look at this x square plus h square now. Now you know this very well that your L1 square has come out to be equal to this, but this x square plus h square is equal to what? You have found out over here in the previous slide. In the previous slide you have found out what? Let's look at over here. X square plus h square is equal to 2rx. You have found out, right? This is your equation A. So over here what will happen? Instead of this x square plus h square, just put 2rx. So what do you get? What do you get then? So you will get something of this kind. Okay, L1 square is equal to u square minus 2ux plus 2rx plus 2rx. Okay, like this you got. Now L1 is equal to u square minus 2x means plus 2x r minus u to the power half by taking the square root. Okay, and u will come out of this 1 plus 2x r minus u divided by u square, okay, to the power half. You have taken basically u out of the square root. Okay, now x tends to your 0. What is the value of x over here? This expression will be much smaller than 1. This particular expression will be over here. This expression will be much smaller than 1. So as it will be much smaller than 1, so we can apply the binomial approximation. What is your binomial approximation? Tell me. Your binomial approximation is 1 plus x to the power n comes out to be equal to 1 plus nx if your x is much smaller than 1, right? You have learnt all this. So your L1 will be equal to u times of 1 plus 2x r minus u, that power half which was over there, that power half has come in the form of 2 in the denominator. Okay, so these 2 and these 2 will cancel out now. So your L1 has come out to be equal to u into 1 plus x r minus u divided by u square. Okay, this is the thing which you get from here. Now what will you get further? Let's suppose this is your equation number 2. So what do you get further? Now this is your equation number 2. Similarly, on a similar line by mathematical induction, if you look at the figure, you will find one thing very clearly. Which thing? Okay, see, look at the figure. The situation, what did you get for u? What did you get for u? For, you see, this is your u. Okay, this is your u. This is your u, and this is your L1. This is your L1. Okay, this is your L1, and this is your u. Okay, so what did you get? You got L1 and u with u. Okay, you got L1 and u with u. Now over here, this is v, and this is L2. This is L2. Okay, even if we try to draw the situation systematically, even then I can tell you, see, let's draw the systematic figure. You might not understand it properly over here. See, this is what, this is your AO. Okay, and this is what, this is your paraxial ray L1. So this is what your u. Okay, and this is the reflected ray, this is the incident ray, this is reflected ray, this is your normal. Okay, this is equal to your L2, and this is what, this is your v, and this is your u. So u L1 and v L2 are corresponding terms. Okay, u corresponds to L1 and v corresponds to L2 from here. So by mathematical induction, we can write one statement. For L1 we got this, right? So by mathematical induction we can write a similar expression for in terms of v also. We don't have to derive it again and again. Okay, so similarly what can you write? Similarly you can write L2 is equal to your v into 1 plus x r minus v divided by v square. Okay, this is your what? This is your equation 3. Okay, now you have got the value of L1 and L2, right? You have got the value of L1 and L2. Now according to Fermat's principle, now apply the Fermat's principle. According to Fermat's principle, what will happen according to Fermat's principle? L is equal to your extremum. Okay, according to Fermat's principle. So what will happen? L is equal to your L of x, clearly, because L is equal to your L1 plus L2, and L1 and L2 have come out to be a function of x, right? L1 and L2 is like this, which is a function of x, because everything else is constant. Everything else is constant, only x is variable. Only x is variable, everything else is constant. So L2 is a function of x. And your L1, what is your L1? Your L1 is also a function of x, because everything else is constant. So when you write the overall L, when you write the overall L, it will be a function of x, because L is equal to what? L1 plus L2, right? So your overall L will also be a function of x. So from here, L is equal to L of x, and you will apply basically Fermat's principle that this is extremum, that is its single derivative is equal to 0. That implies d by dx of all this stuff, u plus x r minus u divided by u plus v plus x r minus v divided by v. This whole stuff d by dx. Okay, what will it be equal to? It will be equal to your 0. Now d by dx of this stuff is equal to 0. D by dx of this is also equal to 0. Okay, and over here these are constants, so this will come out, and differentiation of this is 1, differentiation of this is 1, these are constant, they will come out. So what do you get finally? So finally what did you get? Finally you get a situation which is something like this: 0 plus r minus u divided by u plus 0 plus r minus v divided by v, which is equal to your 0. Okay, so that implies your r minus u divided by u plus r minus v divided by v is equal to your 0. Okay, This is the situation you get. Then what do you get further? You get r by u minus 1 plus r by v minus 1 is equal to 0. You get further. Then what do you get? You get r common from here. So 1 upon u plus 1 upon v is equal to 2 basically. Okay, you get like this. Then what do you get finally? 1 upon u plus 1 upon v is equal to 2 by r you get finally from here. All these are simple mathematical manipulations. So and now f is equal to r by 2, you know this very well. So substitute here, it will be equal to 1 by f. Okay, so you derived the formula basically. This you have learnt in the 10th class. Focal length is equal to the radius of curvature divided by 2. So spherical mirror formula has been derived using Fermat's principle. Thus we can derive spherical mirror formula using Fermat's principle. This is one of the important applications of Fermat's principle. Okay, so thank you very much.